because
Yeah, it's oh,
So you need those because one is for the audio here and one is online apparently.
Okay, that's
Done this morning.
Okay.
So actually, it might be worth putting the laptop there now.
Yeah.
Just so
So we should
that's picking you up, by the way.
Beautiful, Sean. Sorry.
Speak with your eyes. No, but I think we can actually do that because I will open it at the last minute, so I say battery. Yeah.
You want to check where I'm going to stand? Oh, sorry. Good. Good. It's okay.
On the other side.
It says it there.
All right. Good evening and afternoon. Welcome back, William. I'm Bimo, the scientist. It is my pleasure to announce the start of the next session tonight, which is about Southern Ocean ecosystems. And to lead it off, I'll give the mic to Dr. San.
Thank you very much for that introduction. So as I've been generously introduced, we are going to talk this evening about Southern Ocean ecosystems. And we're really emphasizing the need to increase our understanding, the research efforts that are underpinning our understanding, and the protection that we are affording these vulnerable ecosystems. So just to make sure we all understand, I'm going to define what an ecosystem is. So this is a diverse range of living organisms, all the way from the tiny microscopic phytoplankton and algae through zooplankton, fish, squid, right up to the higher trophic levels, the invertebrates that you might find in the deep sea, like on the left-hand side here, marine mammals and seabirds. So that's what we're talking about here, and the need to protect these ecosystems from the impacts of climate change and the direct impacts of human activities within the Southern Ocean itself. And it's a great pleasure to represent the Southern Ocean community here and some key organizations working within science and policy in this region, who I'll introduce a little bit later on. So I just want to take a couple of minutes to explain why the Southern Ocean is important beyond the Southern Ocean. And that is because the processes happening there have impacts worldwide. And if we just look at this map here, this is a map drawn as the ocean surrounded by continents, rather than continents surrounded by the ocean. And what we see is that Antarctica and the Southern Ocean in the middle there occupies a central position in the global circulation throughout the entire oceans. And this means that the Southern Ocean is an important mixer and redistributor of ocean properties, and is therefore responsible for the transport of heat, nutrients, and carbon dioxide throughout the world's oceans. It's also a place where lots of carbon dioxide is exchanged between the atmosphere, the surface ocean, and the deep ocean. And this makes it a critical carbon store, a carbon sink, and therefore gives it great importance in driving Earth's coupled ocean climate system, and ultimately regulating our exposure as one of the species on planet Earth to climate change. And one of the most important physical aspects of the Southern Ocean is Antarctic sea ice. This is one of the largest sources of natural variability anywhere on planet Earth, and it's regulated on a seasonal basis. So every single year, by a cycle of advance during the autumn to the winter maximum, which you see on the left-hand side, and then the subsequent retreat of ice during the spring to its minimum extent in summer in the middle. And what we see is a huge difference every single year between the maximum and the minimum. Perhaps you can't see the numbers on the screen, but in winter, the sea ice extent is 18 million square kilometers. In the summer, that reduces to just over 2 million square kilometers. So huge mode of physical variability in this system. And this drives huge variability in the processes occurring. So the biology and the chemistry of this ocean system is very tightly controlled by sea ice. And therefore, the seasonal cycle of sea ice drives the seasonal cycles throughout the Southern Ocean and within its ecosystems in habitats, species, and the processes that link them together. And the sea ice dynamics, as we call them, the seasonal cycle, is changing as a result of climate change. And I'm just going to show some evidence of how we know that. So these plots show us the trend in monthly values for the winter maximum at the top in September, at the end of winter, and at the end of summer in February along the bottom. So these are the average values for September compared to the average for the whole time period, which is since 1979, when the satellites first started to make reliable observations of Antarctic sea ice. And just by a quick look at these plots, we can see that over the whole time period, there is no statistically significant overall trend. It's more a picture of immense variability from year to year. And one key thing to remember is that these are values for the entire Antarctic, and therefore they hide a lot of regional variability. So in some parts of the Southern Ocean, the trend in sea ice extent is one of decline with consequences on the ecosystem, and elsewhere the trend is one actually of an increase in sea ice over this entire time period. But what we can see at the Antarctic level is that since the season of 2014-2015, we've seen a rapid drop-off of sea ice extent in both the winter case at the top and the summer case at the bottom. And this suggests that Antarctic sea ice was resilient, was coping with the impacts of climate change up until a certain point, but we surpassed that point a few years ago, and we are now expecting a regime where there is less sea ice year on year. And these changes in sea ice drive fundamental changes in habitats and species that are reliant on the sea ice, and the way that they are joined together in the food webs of the Southern Ocean, and therefore the functioning of the entire ecosystem. And as I mentioned earlier today, the Southern Ocean ecosystems also have very valuable ecosystem services that they provide to global society. So human beings all over the world benefit from the processes happening in the Southern Ocean. So as the sea ice changes, the system changes, benefits for humanity from this system also change in the hands of climate. So I'll talk a little bit now in terms of how we know what we know. We have other excellent speakers who will go more into detail about the science, but I just wanted to show this slide to talk a little bit about how research and policy in the Southern Ocean actually happens. So it's a very international and multidisciplinary community organized into several groups and organizations, each of which do something slightly different in a different way and involve different people. And within this side event here at COP27, we have 4 of those major organizations represented. So those are the Southern Ocean Observing System, which prioritizes the collection and the delivery of observational data of the status and change of the Southern Ocean, and makes it available to the scientific community as well as practitioners, policymakers, and educators. We have ICED, or Integrating Climate and Ecosystem Dynamics in the Southern Ocean, which is a program, a regional program of a big international organization which focuses on the biology and chemistry of the oceans. And that is represented here today by Dr. Nadine Johnston from the British Antarctic Survey. So she will give us more information about how the ICE program uses observations and models to perform assessments of the status and change in the Southern Ocean, and importantly, makes that information available to policymakers where it can have real impact. We have the BEPSI working group, which is probably the catchiest acronym. And this group is a working group which focuses on sea ice biochemistry. So the biological and chemical processes happening in sea ice, the exchange between sea ice and the surface ocean. And BEPSI is represented here today by Dr. Sebastian Moreau from the Norwegian Polar Institute, who will be talking later in the session. And finally, we have the Scientific Committee on Antarctic Research and its Anticon research program. And Anticon focuses on conservation in the Southern Ocean and really makes big steps forward in how scientific evidence can be translated into a way that is helpful and productive in terms of policy making around conservation specifically for Antarctica and the Southern Ocean. And all of this is taking place within the context of the UN Decade of Ocean Science for Sustainable Development, which is an ongoing initiative. It started last year and runs till 2030. And this is really driving a major step change and acceleration of our research and our understanding of the oceans globally, and very importantly, how they support ecosystem services to human beings and therefore provide societal benefits at the global scale. And it's important to note that the last couple of decades of Antarctic and Southern Ocean research is actually set on the backdrop of over 100 years of international collaborative research and exploration in the Antarctic region. So we've got this historic landscape and backdrop of Antarctic and Southern Ocean research, and then initiatives which are alive and growing now, which are really accelerating this research progress and making real inroads into translating science into usable evidence for policy so that we can meaningfully protect and conserve these ecosystems in the long term. So what we're going to be talking about for the rest of this session is exactly that priority, the fact that we need to protect the Southern Ocean and its ecosystems from both climate change and the direct impacts of human activity within the Southern Ocean and Antarctica itself. So we've got three great speakers, and I'm going to hand over to the first of those speakers now, who is Dr. Nadine Johnston from the British Antarctic Survey. And she is going to talk to us all about the Southern Ocean ecosystems, give us more detail in what I've spoken about, and to present the key findings of the marine ecosystem assessment for the Southern Ocean. Nadine, over to you.
Thank you very much, Sean, and it's a real pleasure to be here today talking with you. Just to check that you can all hear me. Good, fantastic. As Sean mentioned, I'm representing the ICE program and one of our core activities over the past few years, which is the marine ecosystem assessment for the Southern Ocean, or MISO. So I'm from the ecosystems team at the British Antarctic Survey, but of course I'm here talking on behalf of the entire international and multidisciplinary MISO team. A bit closer. Okay, so Southern Ocean ecosystems are globally important. They are under pressure and they need our protection. And the scientific evidence speaks clearly. So over the past few years, MESO has conducted a large-scale and systematic assessment of their status and change based on the best available scientific and evidence and expert opinion. We've looked at past changes, present changes, in order to determine how dangerous future climate change will be for them. And we've captured the full spectrum of the ecosystem, from the biogeochemistry through to the biology, from the phytoplankton to the whales, and from the seabirds right down to the benthos. We've looked at their food webs across a range of habitats, from the ice shelves and coastal areas, the sea ice, the open ocean, down to the sea floor. And we've synthesized how these species and communities interact with one another and their environment across a range of spatial scales across this ocean and beyond, and also the range of processes or functions that they perform and the threats that they face. And this research has highlighted the need for the implementation of global and local policies to system. So during this presentation, I'm going to give you 5 take-home messages about these ecosystems. That's all right. Ecosystems and what we can do right now to protect them. So it's important to remember that the Southern Ocean formed about 25 million years ago, and over this time it has been cool and thermally stable, and this has given rise to beautiful, unique, and highly productive ecosystems, forging living in one of the most hostile but awe-inspiring areas of our planet. And although the Southern Ocean is remote from many of us and devoid of native populations, unlike the Arctic, it's far from isolated. It's home to a resident and community. It takes seasons of the Southern Ocean miracles. Others, like zooplankton and larval fish, are swept across the ocean passively, swept across the ocean boundaries into waters further north, connecting ecosystems far remote from the Southern Ocean. And as Sian has already explained, the deep waters of the Southern Ocean also carry the nutrients they produce throughout the world's ocean circulation system, fueling ecosystems right across the world. And as they go about their daily business, these ecosystems support a range of globally important processes that benefit humans and society, such as biodiversity, carbon and nutrient cycling, climate regulation, fisheries from Antarctic krill, which have a biomass that's greater than any other multicellular living species, and also fisheries for finfish and wildlife tourism. So in this myriad of ways, Southern Ocean ecosystems not only influence global systems, they are influenced by global systems, and they are absolutely integral to the provision of a healthy biosphere, food security, iconic species such as emperor penguins and the keystone Antarctic krill, and also for human well-being. Message number 2. Southern Ocean ecosystems are threatened by a range of global and local scale drivers. And these global scale drivers are primarily from human climate change. And the local scale drivers operating at the Southern Ocean region are largely the result of other human drivers, such as fishing, tourism, and pollution. So in combination, these pressures are impacting Southern Ocean habitats and the species within them. Crucially, the Southern Ocean has absorbed much of the extra heat and the carbon dioxide associated with global climate change, and has continued to warm and acidify in recent years. The circumpolar winds have strengthened, and we've seen changes in some areas in sea ice thickness and extent, as Sian explained, and the retreat of glaciers and ice shelves. And my colleague Seb will go into further detail on these sea ice ecosystems in the next presentation. Message number 3. Southern Ocean ecosystems are already changing. So owing to that long evolutionary history, that 25 million years, many Southern Ocean ecosystem species are adapted to a cool and stable environment. Their life cycles are really tightly connected to the sea ice, and they are vulnerable to ocean acidification. So this means that they're particularly sensitive to global climate change. And that goes in tandem with that range of other global and local scale pressures that they face. And a few important species and groups, such as phytoplankton at the base of the food web, Antarctic krill, that keystone species in the middle of the food web, which connects also down to the benthic communities. These three groups have a central role in structuring these ecosystems, and by that I mean who is who and who eats who is present and who eats who, and also performing key processes, including carbon and nutrient cycling, as we mentioned, the transfer of all of that energy up to support the vast biological populations of the Southern Ocean, underpinning those fisheries and also wildlife tourism. And changes are being observed across a range of biological space and timescales. For example, at that base of the food web, we have seen changes in the timing, the intensity, and the duration of phytoplankton blooms. We've seen changes in the distribution and abundance of krill over the past few decades, including the areas where they are fished and those areas where predators rely on them. We've also seen changes in the numbers and the breeding success of penguins, such as the Adelie penguins. And historical fisheries have removed much of the great whales. And although some species are recovering, such as the humpbacks, the numbers of many others are very low. And global pollutants, such as microplastics, are increasingly found in Southern Ocean biota. So number 4, continued changes in Southern Ocean ecosystems will have global consequences. The IPCC assessments tell us that there will be increasing threat from climate change and other human drivers into the future. So based on our understanding through the MESO study and that rich history of research that Sian talked about, our understanding of the past and present changes, we anticipate further changes in the structure of Southern Ocean ecosystem and the key processes that they perform. And ultimately, this will affect the role of these ecosystems in the Earth system and the benefits that they currently provide society. And finally, concrete action is needed to protect Southern Ocean ecosystems. There are, of course, challenges in understanding the complexities around the issues that I've raised. Uncertainties and unknowns remain. There's more to unravel about the mechanisms involved, and large areas of Southern Ocean remain unexplored. We need to develop robust projections of future ecosystem changes across a range of space and time scales. We also need wider stakeholder engagement because the impacts of climate change on Southern Ocean ecosystems matter to us all. So all aspects of our diverse societies across the world need to be engaged, they need to be involved. We also need better science policy communication. But despite these, we know enough to act. We know that change is now obvious. We know that more change is locked in from those current emissions, and the resilience of these ecosystems is imperiled with delayed action. So what do we need to do now? The message is simple. We need the implementation, not the words, not the pledges, not the promises, but the implementation of global policies on climate change mitigation to limit or reduce that warming and sea ice loss. And secondly, this needs to happen alongside the implementation of more local conservation and management measures, which my colleague Gilda will go into further detail in the next presentation after Seb. So these measures need to be proportionary, They need to be responsive to climate change and other human impacts, and enhance the resilience of these ecosystems so that they can continue to support a healthy planet. Thank you.
Thank you, Nadine, for an excellent insight into the research that you and your team have been doing for the last couple of years and what it's told us about the fragility and the resilience of these Southern Ocean ecosystems. So we're now going to talk a little bit about the role of sea ice. I introduced the fact that sea ice is a thing and shows great variability, but there's a lot more to the story than that. And it's a pleasure to hand over to Dr. Sebastian Moreau from the Norwegian Polar Institute to tell us more. Seb, over to you.
Thank you, Sean. Thank you very much for the the introduction. Okay. Is that good? Can you hear me well? Cool. Okay, so thank you very much for the introduction and for this fantastic opportunity to be speaking here at the COP27. It's really a pleasure also to represent the BEPC community. And I would also like to thank my sponsors, the Norwegian Infrastructure Project Tuna and SUS, the Southern Ocean Observing System. So as Sean told you, today I'm going to be speaking about sea ice, the importance of sea ice biogeochemistry in the Southern Ocean ecosystems and the Earth system. And I'm presenting this talk on behalf of the BEPC community. So the Southern Ocean sea ice covers up to 17 million kilometers square. And as you know, you must be knowing from now that sea ice is the thin slab of ice that covers the surface of the ocean. It's about 1 or 2 meters thick. And in the Southern Ocean, sea ice forms close to the coast in the fall and the winter before it drifts northward towards the deeper ocean, where it will melt in the summer. And with this seasonal pulse of growing, drifting, and melting, sea ice transports fresh water and various elements from the Antarctic coast to the deep ocean. Antarctic sea ice is unique. It has unique biological, biogeochemical, and physical processes associated to it. As a consequence, sea ice supports all 4 ecosystem service categories, so supporting, provisioning, and regulating. And this sea ice in the southern so okay, I'm sorry. Yeah, I could start seeing some looks. Yeah, okay, my bad. So those are the ecosystem services that sea ice is important about, that sea ice provides. Supporting services, provisioning services, cultural, regulating services. This is why sea ice in the Southern Ocean is so important for us who want to fight against climate change. So this is the goal of my presentation today, is to convince you about this importance of the sea ice, biogeochemistry, and ecosystems. All right. I was afraid I was going to miss this one. The first message for me that sea ice is a very productive environment. We often very high biomass sea ice of magnitude high we measure, and all of these pictures are here to illustrate the point. You can see these very striking brown or green colors that come from the algae that grow inside the sea ice. And an important number is that the sea ice algae production can represent 10 to 30% of the total primary production in the sea ice covered waters, the rest being attributed to production by phytoplankton in the ocean. And it's also important to know that the production in the sea ice takes place early in spring, so November, December in Antarctica. And this is before the production in the ocean can take place. Okay, yeah, got that one. The high biomass inside the sea ice is important for a number of reasons. First, the first one, it draws down CO2 from the atmosphere, which is a good thing to fight against climate change. The second one, it also helps to export this CO2 down to the deep ocean. And this happens when the sea ice melts and releases the algae to the ocean, and they will then slowly sink towards the deep ocean. There, the CO2 can be sequestered, can be stored for hundreds of years, which is a very efficient way to fight against climate change. The sea ice algae can also seed the atmosphere. The important thing about this sea ice biomass is that it feeds. It's a very important source of food for marine organisms in the Southern Ocean, and particularly krill, that has been talking about. The sea ice algae can represent up to 90% of the food intake that the juveniles and larvae Antarctic krill will eat. And as you remember, sea ice production takes place in early spring when there is no other food in the ocean for krill. This is especially because, as you heard from Nardine Stoke, krill is the #1 keystone species in the Southern Ocean, with many other species relying on krill for food. And krill is oh, okay. Sorry about that one. Again, I did it. Krill is particularly present in the Scotia Arc and along the sea ice zone of East Antarctica. And its total biomass in the Southern Ocean is estimated to be close to 500 million tons, which makes it the animal on the planet with the highest biomass, higher than the biomass of humans, as Sean said. Okay. Another important role of sea ice is that it is the habitat of a large number of species that depend on it for living, for breeding, for foraging. These species range from the microcellular ice algae to the zooplankton, the fishes, the flying seabirds, the penguins, the seals, and the whales. And the shrinking of the sea ice cover in the Southern Ocean could disrupt their life cycle. And unfortunately, we are already seeing such an example in the waters of the Antarctic Peninsula. So, over the last 40 years, sea ice in the Southern Ocean but in the was extremely fast towards similarly to the Arctic Ocean. So this is what you can see in this graph here on the right with this page. And together with other climate change stresses, such as ocean and atmospheric temperature increase, the shrinking of the sea ice cover in the waters of the Western Antarctic Peninsula has already led to changes in the marine ecosystem. So we have seen that the primary production has decreased by an overall 12% in these waters, with decreases in the north and increases in the south. And we also saw changes in phytoplankton decomposition, with changes from large cell to small cells. Probably because krill are less capable of grazing on small phytoplankton. The krill we have seen changes in the krill densities as well that Nadine has mentioned, and a contraction towards the south. And there is also evidence that krill being the south is a gelatinous and flat nutritious bill. So and also change the penguin. Another very important role of sea ice is to provide iron to the Southern Ocean. So the Southern Ocean is deprived of iron. And this is the main factor that limits the primary production in the Southern Ocean. And there, the sources of iron are very limited in time and in space. But sea ice is a very important reservoir of iron. Due to physical, chemical, and biological processes, when it grows, sea ice binds a lot of iron inside. And the concentration of iron that we measure inside the sea ice are much higher than what we can measure in the surface ocean. Sorry. So when sea ice drifts offshore after forming, and when it melts in the summer, it releases this iron to the surface waters of the Southern Ocean. And this is a very important process because by releasing this iron to the surface ocean, it allows phytoplankton to grow and to capture more atmospheric CO2, which is a good thing, again, for us who want to fight climate change. So the very important processes I have shown you are far from being fully understood. And there are many other processes by which sea ice is helping us to fight climate change. But one major problem for us is the small spatial and temporal coverage of sea ice studies, which is due to the heavy constraint when it comes to fieldwork in Antarctica. And one way by which we have taken this problem is by compiling all the existing data together. And by doing so, we have created large-scale databases of sea ice processes that would hopefully cover the entire season in the broader Southern Ocean. But this is, however, not enough, and we need to increase our monitoring of sea ice processes, especially in times of climate change. Indeed, after decades of apparent stability, Antarctic sea ice is now declining. The first tipping point happened in 2016, as you can see in this top right graphic. And since then, the decline in Antarctic sea ice has been going faster than in the Arctic Ocean. For example, in 2022, you can see that the Antarctic sea ice extent was under the long-term average for the entire year. And unfortunately, the climate models also predict that the decline in the Southern Ocean sea ice will continue along with further climate change. And this is a major problem because we do not know yet the consequences this will have on the sea ice biogeochemistry and the ecosystems associated to it. But as Nadine presented to you, these consequences are expected and may have large impacts on the ecosystems and the critical services they provide to the global human population. So this is why we need climate action as soon as possible to protect one of the Earth's most unique and beautiful environments. And this is what Gilda is going to tell us about.
Thank you, Seb, for a fascinating overview of the importance of sea ice and the processes that happen there and what they mean for the water column and ultimately for us as the global human race. So I'm just going to take a quick minute just to say that we do have an online audience as well as the audience that's here with us in Egypt. And by the same token, we have two additional members of the team who will be joining us for a panel discussion after this next talk. And we will be taking questions from the audience during that time. So whilst you listen to the final talk, be thinking about what your key challenging question for the speakers in Egypt and joining us online might be. So with that, it is my pleasure to move more into the what do we do about it kind of area of this side event. We've heard some fantastic cutting edge science from both Nadine and Seb, building on that long history of Antarctic research, innovative, leading research that's happening now. But what do we do about it? And in order to walk us through this, it's my pleasure to hand over to Dr. Gilda Cacavot from the Institut Pierre Simon Laplace, who is representing the SCAR, the Scientific Committee on Antarctic Research, scientific research program on Antarctic and Southern Ocean conservation. Gilda, over to you.
Thank you, Sean, and good evening, COP27. So with that introduction, I'm just going to go right into it. So what have we been talking about this whole session? Climate change is impacting the Antarctic now. That's what Nadine and Seb have been telling us throughout this whole talk. We've been seeing it on the level of ecosystems over on an entire circumpolar scale, and we've been seeing the impact that changing extents, variability in sea ice is causing for those ecosystems in order for them to be able to deal with the climate change impacts that we're seeing now. What can we do about it is the question. Now, I don't want to come here and paint a whole doom and gloom scenario for you. I want to actually try to talk about solutions and strategies. That's going to be my goal for the next 10 to 15 minutes. For me as a scientist, I see this as a way that we can look at this in two ways, for example, or two steps. How do we transform science into action? And what are the actual actions themselves that will support climate mitigation and ecosystem adaptation and resilience? So, starting with the science that we need to inform action on climate change, much of that was already presented by my colleagues here this evening. What I want to emphasize about the science that's needed is that it's continuous. What we know now is what we know now, but climate change is dynamic. The reactions that the ecosystems around the Southern Ocean are having today are not the ones that they're necessarily going to be having tomorrow. And the projections that we're nonetheless making for tomorrow have uncertainty inherent in them. And so research and monitoring that is continuous is needed to support conservation and management strategies that need to be as dynamic as the ecosystem responses that we're observing. And so these types of activities, which can include international research efforts that are happening now, improved modeling, improving new technologies and observing systems to actually know what's happening on the ground in the Southern Ocean. Again, this is a place that's hard to reach. So we need to be creative about how we're getting the research and monitoring down there happening. And how can we improve modeling and projections to move into the future so that we can understand how ecosystems are responding and we can address this inherent uncertainty in the system to improve our projections, to improve our conservation and management strategies. An overview of science landscape looks like in the Southern Ocean. So I like to think of this as a two-way street. So we have the science community and we see series of committees that are taking that information, synthesizing it up to actual policy actors in the Southern Ocean. And the reason why I like to think of it as a street is that we need input from policymakers as scientists so that we can understand what is the science that they need for their decision making. We as scientists also have to be engaged in this process so that we can communicate to policymakers what we feel is the policy relevant work that will address the needs that we're identifying in the ecosystem. So starting at the bottom here, we can think about general science assessments. So these can come from the Intergovernmental Panel on Climate Change, the IPCC reports on a global scale, as well as what has recently been in the Southern Ocean system assessment of the Southern Ocean, MESO, ecosystem changes in the Southern Ocean in particular. And so these science assessments are fed into science coordination organizations. So these include working groups from the Commission for the Creation of Antarctic Marine Living Resources, which my colleagues have spoke about, the Standing Committee on the Antarctic Treaty System, and the scientific research program that I'm representing here, ANTICON. So what these science coordination groups do is then they feed into these committees that advise our policy-making organizations. So that's the CEP for the Antarctic Treaty System, or the Committee for Environmental Protection. We're on the second row, by the way. And or we have the Scientific Committee to CAMLAR. And so what these committees are now doing is they're taking the synthesized assessments, taking the policy relevant messages out there, and giving those to the actual decision makers in the Southern Ocean. And so it's the meetings of the Antarctic Treaty System and the CAMLAR Commission that are the ones that are ultimately deciding policy in the Southern. So this review now become, what does effective policy look like? And we can think of global and a local scale. And starting from the global perspective, we know, and this has been touched on by my colleagues already, global decisions will affect the rate and the impact of change in Antarctica on local and regional scales. And so what we know in order to mitigate that global driver is that we need to commit to lower emissions and global climate change mitigation strategies. That's the only way that that global impact on the Southern Ocean is going to be mitigated. But we want to think also about what we can do in the meantime, because obviously we can't necessarily control what's happening on global international scales. What can we do as scientists informing policymakers and as the policymakers working in the Southern Ocean to mitigate the impacts that we're already seeing of climate change? So first, we have to deal with the high level of uncertainty and data gaps that are inherent to Antarctic science, again, because of the difficulty of working there and because of inherent uncertainty in science generally. And so in order to foster a conservation strategy that achieves resilience in our ecosystems to climate change impacts, we want to go for management strategies that are both precautionary and responsive. So I'm going to explain a little what I mean by that. So with precautionary, and we brought this up earlier as well, I mean policy decisions that make allowances for the fact that we know that impacts of human-induced change are happening now. And we're also aware that there are gaps in our knowledge. We're not able to predict exactly the impacts that we're seeing. We in terms of exactly what happen species systems in the Southern Ocean change the environment now. So we need management that's precautionary. We also need management that's responsive. So this comes back to the continuous paradigm. So while we may have an idea of the best mitigation strategies for the impacts we're seeing now, these might not be the best mitigation for the impacts that we will see in the future. As we get new data, as we have more science coming in, we need to be able to have dynamic policy responses that change with change around. When we think about who the stakeholders are in the Southern Ocean for which this information is needed, we think about fisheries, for example, we can think about tourism in the Antarctic, and we can think about science logistics that are supporting the scientists working there. One example of the type of local action that we can take in the Southern Ocean is in the form of marine protected areas, or MPAs. So this is one type of action that's both precautionary and responsive. Marine protected areas allow us to foster resilience in the Southern Ocean by minimizing the impacts of local pressures like fishing, for example. They provide for species in marine protected areas where we can reduce the impacts of humans locally. And finally, they provide an area of recovery for species and ecosystems that have been previously impacted by climate change and human activities. The map that we see here is showing us a series of existing and protected marine protected areas around the Southern Ocean. Planned, not sure if I said that right. And so what I want to draw your attention to is that the only colors that are active now are the tiny yellow box up top and the green on the bottom. The green on the bottom is the Ross Sea Marine Protected Area that was passed in 2016. It's the largest marine protected area on the planet so far. All the other colors, the purple, the orange, the pink, are planned areas. Now, CAMLAR, the organization I told you about regulating Southern Ocean extraction, has for the past a decade ago committed to creating a network of marine protected areas around the Southern Ocean, as we see here. But the only one that has been successful in actually being implemented is the green one on the bottom, in addition to the tiny yellow one on top. But in terms of the new ones that we have, only the green one is active. And the issue, and what is the issue then? Why don't we have marine protected areas on the Antarctic Peninsula in purple, or the Weddell Sea in orange, or East Antarctica in pink? And a lot of this is coming from political gridlock. The science behind these marine protected area proposals is solid. It's been presented multiple times, improved multiple times, and it just has not been able to get consensus from the countries that need to provide it for it to be passed in CAMLAR. So that's going to bring me to my next point, which is about political will as being a critical aspect of how we're going to turn science into policy in the Southern Ocean. We have to live in reality. Again, it's not the best available science that is causing us issues here. It's political will. We as scientists need to think about how we can reframe the value of Antarctic ecosystems, both to the public and to policymakers, so that we can move beyond this exploitation or conservation binary, which is often something that's gumming up the works in many ways in science, in policy in the Southern Ocean. There's lots of potential approaches in how to do this. Quantifying the value of ecosystem services in the Southern Ocean is one potential way. Integrating social cultural perspectives into our perceptions and understanding of the Southern Ocean ecosystems is another potential avenue for how we can address this, but certainly something that the sort of next frontier, let's say, to science in policy. My conclusions. I want to come back to the point that we continue to emphasize in this session, which is that we're seeing the impacts of climate change now in the Southern Ocean. And so the question is, what is going to happen if we don't take action? What are the consequences of our current gridlock and these issues? And winners and losers of the Southern Ocean. Seb and Nadine have brought this to some extent. The shift from krill to south energy pathway deprive systems of the level of nutrients that they were originally having access to. Changes in penguin populations in, for example, the Antarctic Peninsula, where we're seeing areas with increases in Gentoo penguin populations, where in the same area, precipitous drops in the number of adults that we're seeing. Ultimately, we have to think about the fact that we as humans are stewards of ecosystems, including in the Southern Ocean. We have to ask ourselves, what are we willing to lose with respect to biodiversity in Southern Ocean ecosystems, the complexity of these ecosystems, and not even just thinking selflessly in this way. We have to think about the risks that we're engendering to ourselves, to future food security that my colleagues have touched on, to whatever downstream impacts that we cannot yet predict that having loss to biodiversity and complexity in ecosystems may in the cause. I will close with this vision of different types of futures that we can expect from Southern Ocean at different global warming levels. So these 4 maps showing us the extent to which sea surface temperature and sea ice extent will vary depending on either 0 top left, 1.5 degree increase top right, 2 degree increase bottom left, or 4 degree increase bottom right. At a 1.5 degrees Celsius increase in average temperatures, and these are all at the end of the summer, we're starting to see an increase in stressful levels of sea surface temperatures moving down from the Antarctic Peninsula towards the Ross Sea area. This is going to be a problem for ice-dependent species who are now going to see their ranges being restricted by this temperature increase. At 2 degrees, not only are we seeing an exacerbation, and we're looking on the bottom left, not only are we seeing an exacerbation in the sea surface temperature increases and sea ice losses permeating down from the peninsula, but we're seeing impacts in the East Antarctic as well. These changes are going to have impacts on ecosystems on a circumpolar scale in the Southern Ocean. What will be needed to mitigate these changes are to designate parts of the Southern Ocean as refuges. I mean, they're already going to become refuges. And when I talk about refuges, I'm talking to an extent of these areas, systems that are becoming further and further at risk in the Antarctic Peninsula. These are areas that they are going to be having to rely on for their continued survival. And so it is think about as because of their value in the impact in the ocean in these different scenarios of that we can have in front of us and know that this is going to be what we're going to be dealing with and how management needs to respond. And so finally, on my closing note, the last year, global warming level must remain below 2 degrees Celsius in order for ecosystems in the Southern Ocean to be able to have resiliency, refuge, and recovery from these impacts. And there's lots we can do on the local scale to try to help those ecosystems to achieve that. But ultimately, it's a global decision that's going to decide much of the fate of ecosystems in the Southern Ocean. Thank you.
Thank you, Gilda, for really moving to action at the at the end there on some really strong recommendations as to what we actually do with all of this science in terms of informing useful policy. So Gilda talked about the regional scale management and governance frameworks for the Southern Ocean in the shape of the Antarctic Treaty System and the Commission for the Conservation of Antarctic Marine Living Resources, CAMLR, and of course of very great relevance to this conference here, the global decision making, so the mitigation of climate change at the global level actually falls within the auspices of the United Nations, and of course, in particular, the United Nations Framework Convention on Climate Change, the UNFCCC. So what we are doing here is really giving a call to action to both of those governmental and management frameworks for urgent, decisive action at the scale required to protect Southern Ocean ecosystems. Now, I can see we've jumped the gun a little bit with switching to the speakers. Could I please have the summary slide before we switch to the panel? And we'll come back to our speakers once I've just given an overview of the key take-home messages. So, slide number 35, please. So just whilst we're getting back to the summary slide, I hope we can agree that the quality of the presentations from our three speakers has been absolutely outstanding. And hopefully you picked up the key messages that run through all of those presentations. And hopefully we've managed to convince you over the last hour that Southern Ocean ecosystems are important at the global scale in terms of biodiversity, nutrient cycling and distribution throughout the world's oceans, the uptake of carbon, and therefore the regulation of climate, and the Southern Ocean doing us a huge favor in terms of helping us to mitigate climate change through natural mechanisms. Southern Ocean ecosystems also provide critically important ecosystem services for the human population worldwide, both those in the Southern Hemisphere close to the Southern Ocean, but also those throughout the global human population. But these systems are sensitive, they are fragile, and so they are very well adapted to the environment, and the functioning of these ecosystems is very reliant on these systems have been set up over hundreds and thousands of years. So they do not have much capacity to adapt to climate change. And this means that climate change mitigation at the global scale is really the only solution for protecting these ecosystems now and into the future. We heard that sea ice plays a critical role in regulating all processes in the Southern Ocean. And this sea ice is changing and therefore driving changes that cascade through the entire system, as well as having global implications because of those global connections of Southern Ocean processes. So I'd like to close the talks before we move into the panel by really making the statement that urgent action is required from two directions, and those two directions need to be complementary. So at the global scale, we need urgent reductions in greenhouse gas emissions. It makes a real difference to these ecosystems whether we limit warming to 1.5 degrees, 2 degrees, or whether we fail in our target to meet the Paris Agreement. At the local scale, we need local conservation and management to enhance the resilience of these systems to changes in climate that we have already committed to. But in terms of longer term, if we have urgent, direct action starting immediately, then we can safeguard these ecosystems and we can prevent irreversible deterioration, and we can ensure that the ecosystem services and the benefits to the entire global human population can be safeguarded now and into the future. The question is, will we? So we really call on the negotiators here at COP27 to raise their ambition, make meaningful commitments to limiting warming to 1.5 degrees, and to delivering on those promises, and to entraining the whole of society to act in terms of climate change mitigation and adaptation, and financing those things at the international level, the national and local level. So that I would now to the panel discussion. So I'll just use the speakers as they are coming up onto the stage. So I'd like to invite the speakers from the sessions come and join me on the discussion sofa here at the front. And I'd also like to, and it is fabulous to have you joining us. I'll introduce you in turn. On the bottom of your screen, we have Dr. Andrew Constable, who was the leader of the Marine Ecosystem Assessment for the Southern Ocean. And he's joining us from Hobart in Tasmania, Australia. So welcome, Andrew. And on the left of your screen, we have Dr. Mercedes or Mecha Santos, co-chair of the Augmented Committee on Arctic Research, working to into informing Antarctic and Southern Ocean conservation. Mecha, welcome. So it looks like all the technology is working, which is fantastic, a great relief for me. And I would now like to open the floor to questions from the room, questions to the online audience. If there are any, please feel free to raise a hand and tell me that something has come in. And I've also got a live feed to my laptop with another online audience who is following on Twitter. So we have a question here in the audience. We'll see how we get questions and how much more. And,
I'm Robbie Mallet. I study CI at London. So quite a few IC scenarios overshoot a temperature limit and then back off towards 1.5 or 2 degrees. So which part of the ecosystem in the Southern Ocean will benefit from backing off and going back down to a temperature limit, which will be irreversibly changed?
Thank you for that question. And I'm going to come first to Andrew to give your perspectives on the question. Firstly, to check, did you hear the question properly?
There's great uncertainty around sea ice projections. It's one of the biggest uncertainties I see clusters. But some of the models do seem to be behaving reasonably well. In terms of ecosystem effects, things that we find hard to understand at present is the degree to which the system can recover. And the reason why I say this is because there are two main changes of recovery that have been occurring. One is in relation to the recovery of the ozone hole. We're still seeing the impacts of the ozone hole mostly felt around the West Antarctic Peninsula and the sorts of impacts that's there. It takes a very long time to recover in and out of that. The other has been looked at closely is what they mean with the recovery of the whale population after the cessation of whaling in the 1980s. And again, that's some of the whales are recovering and many of the whales are not. There's some cooperation of the system and some changes in other predators. But again, it's not entirely clear what you said. The dangers of an overshoot is that the system seems, as a result of the observations of ozone and whales, the system seems to enter relatively stable states that are difficult to budge back into a recovered historical state. And so I would say it's very dangerous to assume that both physics and biology will recover if there is an overshoot trajectory. I would suggest that the system could well, in many parts, particularly in the Antarctic Peninsula and in the North Sea, may in fact go into an alternative state.
Thank you, Andrew. The gentleman who asked the question is nodding in a very satisfied way with the answer. Metra, I wonder whether I can come to you on this question to offer a perspective from the point of view of how Southern Ocean conservation can help these parts of the system to recover from an overshoot.
Good morning and good evening to everyone. Well, I want to say that I am connected from Argentina. I'm trying, I'm being here in order to be part of this is also to try to bring my perspective from a South American country and my understanding. And to contribute to diversity and equity in discussions. Can you please repeat me your question? No.
Yes, of course. And I apologize for not mentioning that you are in Argentina. So yes, Metra is joining us from Argentina and representing a South American perspective on the issues that we're discussing. So Metra, the question was about overshoot scenarios. And if we exceed 1.5 degrees of warming, and this does a certain amount of damage to an ecosystems, how might they recover as warming decreases again, or conservation have a role to play in making that happen?
Yes, I have some trouble with internet connection, sorry if you lose me. I cannot speak about what will happen if there is an overshoot, but I can give a perspective of how what we can see now, what we can do to prevent or to create a more resilient ecosystem. And that is an example for that. We have an example which is the NPS, the representative system of marine protected areas in Antarctica. Something that Sheila mentioned today, and something that, for instance, there is an NPA proposal in the Western Antarctic Peninsula has taken into account the effect of climate change. And we know that by increasing the protection in the south, we are creating a more resilient ecosystem that will also have a positive impact in the north of the Antarctic Peninsula. One example of this is that by protecting the south and the region where the sea ice extension does not reduce as fast as in other areas, we are protecting a site where there is that is linked with the krill abundance that will impact in the north, and we saw that the populations of endemic, something that also should have mentioned that are decreasing, could be protected by also even protecting the south, not the area where they are living now or feeding, but other areas to deal with the aspect of climate.
Lovely. Thank you very much.
Sorry. To summarize, I give you a vision of how we can make something now to protect what will happen or to prevent what can happen in the future.
Excellent. Thank you, Mecha, for that insight. And that actually feeds in very nicely to a question that we had in advance of the session when we invited questions from the online audience, the big world out there. And that question follows on beautifully from what you've just said. So the question that came in earlier today was, how is climate change incorporated into decision making around conservation and management for the Southern Ocean? So Mecha, following on from what you just said, would you like to take a first go at answering that question? And then we'll come to panel members in person in Sharm el Sheikh.
Okay, yes, thanks. Yes, climate change, we can address climate change more than we are doing now, for sure. But these are one of these examples. No? When we think about the representative system of marine protected areas around Antarctica, we're thinking to protect different environmental habitat for species with a regional perspective, knowing that some other penguins are, if we think around Antarctica, the penguins are doing well, but if we think about the Western Antarctic Peninsula, they are not doing very well, they are doing very bad, as Gina mentioned. So we need to protect the region, that is important for these species in this area, and then have a regional perspective. And we are taking into consideration the effect of climate change in NPA proposals, the ones that some of them has been adopted, as some of them require consensus. And then we have other, for instance, the protection of emperor penguins, and we know they are suffering for the reduction of TIs on very critical habitat for their reproduction. Or we are now, the CAMERA is discussing to have climate change as a cross to be discussed across different management strategies that in relation to fisheries or NPAs, etc. So these are different approaches to that considers climate change. We need to do it better, we need to do it faster.
Great, thank you very much. And I wonder if I can come to Gilda, just in case you've got anything to add to that, perhaps from the context of a more circumpolar view of Antarctic conservation.
So to build off of what Mecha just mentioned, in terms of integrating climate change into circumpolar management, as Mecha said, more needs to be done. I was just at CAMLAR less than 2 weeks ago, and I'm not an old salt at CAMLAR like the folks on the screen are, who have been going since the 80s. I don't necessarily claim to know the history of this organization to the extent that many folks here on the stage today do. But what I do know is there have become connotations to certain concepts like climate change, like marine protected areas in CAMLAR that have made them radioactive. We spent almost 2 hours discussing a paragraph that said something positive about a paper that provided data for the marine protected area proposal around the Antarctic Peninsula. So do you see my point? My point is that this wasn't about passing the marine protected area proposal in the Antarctic Peninsula. It was about a paper that provided data to support the proposal. And even there, the language to use to describe the value of that data had to be so carefully chosen because of the radioactivity of these concepts. And so I want to come back to this concept of political will. How can we reframe the way in which we think about management in the Southern Ocean such that we're not necessarily just thinking of a marine protected area as a conservation tool? It is not only that, it is a fisheries management tool. It improves fisheries catches. Again, I'm not necessarily an expert on marine protected areas, but I think that at some level, we need to change the way we think about these concepts. Also, climate change. Why does it have to be difficult to integrate the term climate change into the updated terms of reference of the CAMLAR working groups, which was something that we were discussing this year? Why is that complicated? It should be obvious. But because there is this binary that if we do one thing, it's going to be bad for security, food security, it's going to be bad for fisheries. It's not. Or rather, it's not that simple. And we're not getting anywhere as quickly as we need to, as Mecha was just saying. So I don't necessarily have the solution here, but I think we need to start thinking more creatively and more three-dimensionally with respect to how we deal with climate change in management in the Southern Ocean.
Thank you, Gilda. And I see that there are a couple of questions in the room, but I also know that Andrew had a short comment to make on this question of climate change incorporation into decision making. So, Andrew, over to you. And if you could be as concise as possible to give time for more questions, that would be great.
There is a general expectation that group production will decline. There is also an expectation that if you look at certain column, that the system may well start to shift towards a fish-based system rather than a krill-based system. These matters have not been taken account of in the fisheries decision, and will need to be because declines in production, if there are no changes in the fisheries management measures, then potentially there will be increased competition between fisheries and predators.
Thank you, Andrew. I think we'll move on to the next question.
So the Antarctic sea ice anomaly trend was pretty neutral, and then now it's trending downwards. Is it fair to say that that's from intricate water warming? You know, intermediate water is warm and very salty, so it's, you know, that's why it's deep. In, you know, it's not at the surface. So is that shoaling and melting the sea ice from below causing that the trend downwards? And is the sea ice trend downwards enough yet to cause increased glacier movement and calving on coastlines in Antarctica?
Thank you for the question. Seb, I'm going to come to you for an answer there.
Okay, I'll give it a try. Thank you, Sean. That's a very good question. There's actually two questions. I think the answer to the first one, we do not know yet the actual reason for this change in the trend in the sea ice concentration. But we do see increases in the upwelling of the warm deep water around Antarctica. So maybe. The answer to your first question is maybe. And your second question is definitely yes. If sea ice disappears, sea ice acts as a buttress when it sits in front of the ice shelves, basically the glaciers that reach the Southern Ocean. So if sea ice disappears, this is a buttress that is not there to slow down the movement of the glacier towards the ocean. So that could be an additional problem.
Okay, thank you. Anybody else, anything to add to that answer? Andrew, do you have something? Yep.
Changes in the physics of the ocean. One of the things that is recently well documented is the increased heat content in the Southern Ocean. And so if there is variability in the shoaling of the warmer, deeper water, the increased heat content is likely to keep the production of sea ice as a sustaining feature of the Southern Ocean. And this is one of the things that is quite troubling about what is now a 6-year trend in decline, which is quite rapid. It's going to have certain polar effects, not just the effects that we've seen on the Western Antarctic Peninsula, but everywhere next.
Thank you, Andrew. And we have another question in the room. Can we have a microphone? And please remember to say who you are and where you're from.
Hi there. My name's Narissa Vax. I was a very small part of MISO from 2018. And I kind of just wanted to, check in after what Gilda said and some of the, we're all here because we want this work to go into policy. And that was the key theme of MISO, was to get those points across. And it does seem quite disappointing in terms of doing that through Camilla, unfortunately. And so I was just wondering if anyone has been thinking differently and whether MISO has been used as a tool in that regard to communicate in different ways, within the UNFCCC, for example, the Antarctic Treaty System, those sorts of avenues.
Thanks for the question. Nadine, I think that's one for you.
Thank you. Thank you for the question. Yeah, it's a really important one. And Camilla and the Antarctic Treaty System is not the only avenue that we've been highlighting our results to. We've been at a number of international conferences and presenting our work there. We've been working individually, each with our own media teams, creating documentation that puts those messages into policy-friendly formats as well. And we've had a strong input into the latest IPCC assessment. And hopefully with continued MISO over the next few years and into the future, we'll be able to provide that continuing input into the IPCC process. So we've got a huge community of over 200 people who were involved in MISO, representing 19 countries. And there's a real strong push from all of those people to get those messages out, and a real drive within them. So we're doing our best to get that message across, and hopefully that work of MISO can continue into the future.
Thank you. And I'm going to come to our two online speakers, Andrew, to add anything else about the policy outreach for MISO, and then Metcha, so you've got some time to think. I'm going to ask about what Anticon aims to do in this space. Andrew first.
We are developing at present and finalising a summary of policy papers. And a key component of that is to have infographics which are able to be used in presentations in schools and help explain the nature of Southern Ocean ecosystems and what needs to happen. In fact, many of the MISO infographics we use in a workshop recently in Chile that help convey many of these messages. So we are looking at more of these outreach activities to try and take this to schools as well as into the professional domains.
Thank you, Andrew. And now I'm going to come to Metcha to talk about what Anticon is doing to continue to push these messages about Antarctica and the Southern Ocean into meaningful information for policymakers?
Yes, thank you. One important thing that I want to highlight today earlier is like that anti-crime includes social science branch between the anti-crime, right? Because we have to think about this as socio-ecological system, not just biological or physical system. We are part of this, and actually, we are the ones that we can find the reason. We need to understand the different visions between countries to take into in our minds the political view or will, the management perspective, and science. Science alone is not enough. Even if we are doing our best efforts, science alone is not enough. As Chica mentioned, we need to understand what management or policymakers need. And in that sense, we are now thinking about working on a workshop next year within stakeholders and cycles. And cycles can provide help or facilitate science that they need, and we are also calling for scholarships for research to go to these meetings to understand what the discussions are and what kind of science is needed to advance or to move forward with the conservation. So these are kind of things that we are having in mind, or we are working on. Another class, we are including part of in our team, we try to be as diverse as possible. We invite people from gender equity, we invite people from all the countries that are part of STAR to be part of this program. We also include young researchers, and after children going home some minutes ago. But we are including young researchers because achievers is one of in all the levels of our work, because they have a vision and an energy and perspective that needs to be considered for this.
Okay, thank you, Mecha. And I see that we are out of time for this session. So I'd like to give a big thanks to our online participants. Mecha, thank you so much for joining us from Argentina. Andrew, thank you so much for joining us from Australia. And I'd like to thank our in-person speakers, Sebastian Moreau, Gilda Cavo, and Nadine Johnston. And I'd like to leave you with our final message, which is that the Southern Ocean needs protection now. The longer that we delay, the bigger a challenge will fight. And systems will suffer, damage we will have to recover from. So we need urgent reductions in greenhouse gas emissions to mitigate global climate change, and we need effective local conservation and management to safeguard these systems and their societal benefits worldwide, now and into the future. Thank you all for attending in person and online, and we would all be delighted to hear from you again with any further comments, questions, feedback, and we hope to see you at the next big UN event where we will keep pushing this message until adequate protection is in place. Thank you.
Thank you, Sean. Thank you, everyone, for making our Polar Oceans Day such a success. This was a wonderful way to end it and a very important message with which to end it. This concludes our live stream for the day from Sharm el-Sheikh. Tomorrow will be Permafrost Day, and we look forward to many of you joining us again to discuss this other important cryosphere dynamic. So thank you again for all the organizers of Polar Oceans Day, and we'll see you tomorrow.